This video will be a challenge. This is a practice video, so I'm not introducing new concepts. We're going to be using the indirect proof and conditional proof and the rules of inference and replacement to try to prove this one. We're going to do this together. I'm not going to be going down into the mechanics. This is strictly about looking at the problem, taking the knowledge that we have acquired, and trying to have the answer. I'll say from the get-go that I don't know the answer to this. I might be the teacher here, but it doesn't mean that I'm not going to struggle. I'm going to have to stop and think about this. I'm going to pause the video when I need to think about things so I don't waste your time, but I would highly recommend, as you're going through this, to pause the video frequently, see what you can solve on your own. Maybe you can solve it all in one shot, in which case that's amazing. But I'm going to walk through it slowly, so we're going to, just like we do in class, I'm going to start off just by pointing out some things, making my own observations, and then hopefully coming to some conclusion, some kind of answer. So the instructions for this, I got this from another logic book. I'll leave the reference in the notes for this video, is that we have to use all of the rules of inference or replacement. Well, probably won't use them all, but we can draw from any of them. And we also should use the conditional or indirect proof. I don't know how difficult this one's going to be. I took it from a section that is supposed to be difficult, but sometimes I'm disappointed in that sort of strategy. Okay, so as I'm starting this off, I see that the conclusion is a conditional itself, which suggests that a conditional might actually be the thing I want to use. So I could start off by assuming K and L. And if I can get to not N, well, that would be easy. That would help me out a lot on this. And so why not? Why not start at that position? So I'm going to start off with K and L. It seems like the automatic place to go. Now, yeah, let's if you would, we're gonna take a look at this and look for patterns. I'm gonna go through what I see, but why don't you pause the video right now and see what you can figure out. All right. So I notice if I start off with this assumption, and I still think that's a good idea, I'm going to write a assumption for a conditional proof here. The nice thing is that premise 1 and premise 2 both start off with a K and an L as an antecedent, and I can simplify this. Now, one question is, should I simplify it all? Should I simplify K and then do modus ponens to get all this, and then do L and do modus ponens to get all that? Well, look, I don't know, but this is what I do know. The conclusion, or the consequent of the conclusion, is not N. And this says not N. That's on the L line. So if I simplify with L, and then using modus ponens I get this, if I can somehow break that all down and get me to the N, that's all I need. If I end with the not N somewhere down this line, then I've proven that K, if K is true and L is true, then N is true, and I may not have to touch premise 1 at all. Maybe, if I'm lucky. So we're gonna go on. I kind of see. I'm thinking I'm seeing right now that we will have to use premise 1, but maybe we won't. We'll see. We'll see. So we got L from 3 simplification, and I encourage you, just stop the video when you want to and see what you can figure out. I would be doing it all the time. Let me give you a hint if you get really stumped, but then stop and try to do something with that hint. I'm just gonna talk through every little ounce of thoughts that I have, and maybe some of them will be hints. So if I have L, what can I do with that? Well, I know from modus ponens we can get this. So I'm going to write on this line Q or R, therefore S and not N. from 2 and 4 modus ponens. Okay. Now, so how do we break this apart? We don't have a Q or R. I'll tell you one thing we could do is we could make another assumption, and our another new assumption might be something like Q. Let's say it's Q. This makes me nervous. It makes me nervous because, you know, I've done a lot of logic problems in my life, and I know that sometimes it seems like there's no solution, so you assume something else, and suddenly you're assuming and you're assuming and you're assuming using nesting assumptions. And every time you do that, you gotta pull yourself back out of it too, and it just makes the problem so complicated. And what I've learned is often I make it more complicated than it actually is. I do a lot of work that leads to nowhere when a better, simpler solution was staring me in the face. So let me think about this a little bit. I'm not ready to make that kind of commitment here. Let me think about this. If I did assume Q, then I can use addition, get Q or R. Then I can get S and not N. Then I can simplify the S and I can simplify the not N. I'd eventually be able to, this is what I'd be able to get. I can put Q, because I would eventually be able to get to not N, which is what we want here, but it's not what is helpful here. But I can get this, if Q, then not N. I can do that. Like, I see how I can do that. Do you? If not, well, we're going to walk through it in a moment. I'm actually going to do it. I'm going to do it. So see if you can figure it out. All right. If you haven't paused it and figured it out, maybe you should try. But let's do this. So we have our Q. We're going to do some addition. We got it right. We do ACP again. We're going to do a little addition. Give me Q or R. This comes from 6 addition. It's important to be neat here so you don't lose what number you're on. With Q or R, we can get S and not N. That comes from 5 and 7 modus ponens. This might all be a dead end. I'm really nervous. What's the worst that'll happen? I just erase it, start over again, and start my fun evening a little bit later than I had planned. But this is fun too. Okay, so we get not N. That simplifies from 8. So that is simplification. Now 10. Since we know in this land of assumptions that if Q is true, then not N is true, then we know in this land of assumptions that if Q, then not N. Okay. All right. We could say at this point, if K and L, then if Q, then not N. We could say that. I'm not ready to say that. I'm not ready to leave because I have another idea. We can also simplify the K. So we can go back up to 3, simplification, and do the same sort of thing. Carry this one out, modus ponens. This gives us M or N, therefore P and Q. That gives us 1 and 11 modus ponens. Okay. Then I'm gonna assume the N. And I'm going to assume the N just like I did up here. Maybe there's a repeated pattern. There's often repeated patterns in these problems. So I'm going to do an N, and this is another. I forget. I'm being bad here. This is from 6 through 9 conditional proof. N, we can say N or M from 13 addition. Then, this is step 15. we are going to do M or N from 14 commutation, then 16. If you're getting a hint of this, go ahead and do it. Pause it, do it. P and Q. This comes from 12 and 15 modus ponens, 17. This will, this gives us, what do we want? I think we might want Q, because there was that Q up here, and maybe, look, if Q then not N, if N then Q, is that going to help us? Is that actually going to be fun for us? I think that'll be fun. At least it'll show us how frustrating logic can be, at the very least, and that's learning something. Learning something is good. Not always happy things to learn, but you'll make progress. We'll get there. 18. No, wait, we don't want to. We got what we wanted. We got what we came for. If N is true, then Q is true. So if N, then Q. And that is from 13 through 17, conditional proof. Feeling good. Feeling good. Haven't had to pause the video yet. I don't know if you'd be able to tell or not. Sometimes I just babble while I'm trying to figure things out, and that's good enough sometimes. We're still in the assumption. 19, if N then Q. And look at 10. 10 says if Q then not N. So if we put 18, 10, you know what I'm going to do? 18, 10. If N is true, then Q is true. If Q is true, then N is not true. So 18, 10, hypothetical syllogism, gives us if N is true, then not N is true. Still in my thingy? Still in my assumption land? Let's use implication. Not N or not N. From 19, implication. Look at this. Oh, I love this feeling. Not N. From 20, tautology. Which means if K and L are true, then we have shown definitively that not N must be true. And if we know that whenever K and L are true, not N must be true, then we can simply express that if the first line is true, then the second last line is true. We know this from 3 through 21. Conditional proof. And then you get to say victory and laugh at the face, in the face of the gods of logic. And that's it. So hopefully you got there. If not, just keep at it. We'll look at some more exercises. I'll put up another one. Yeah, well, you know, next time for the next video, if you let me solve it for you, try to solve it on your own. And I'm going to do this same thing, but hopefully you can get to the answer for yourself before I show you how to do it. All right, that's it. Best of luck. Leave questions or comments. If I was a little too smug or whatever, let me know, and I'll see you next time.